Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 5.2, example 1, and it can be found on page 210. Okay, we have been working with solving systems of equations by graphing. So we get two linear equations, we graph them, and where they intersect is the solution for that system of equations. We know that a system of equations is more than one. So the solution is a point, an ordered pair of point that solves or works in all of the equations or both of the equations. But sometimes solving by graphing is not feasible because the y-intercept is going to be off the chart or the slopes are kind of wonky. So sometimes solving a system of equations by graphing is not feasible. So we have another way of solving a system of equations. We can use substitution. So the book will give us a system of equations that looks like this. Y equals 2x minus 4 and 7x minus 2y equals 5. Now, this is a linear equation. It can be written in slope-intercept form, but for substitution, it does not need to be written in slope-intercept form. What we're going to do, we are going to substitute. So here, this is telling me y is equal to 2x minus 4. So I can use y, or I can use 2x minus 4. What I'm going to do, I am going to substitute this 2x minus 4 in here for y. Because it's telling me y is equal to that. So wherever I have y, I can substitute that in there. So I'm going to substitute this for y, rewrite my equation, and I'm substituting 2x minus 4 for y. And then I'm going to solve this the same way I would solve any equation like we did in Unit 1. So 7x minus 4x plus 8 equals 5. So first I had to distribute. Now I need to combine like terms. So 7x minus 4x is 3x plus 8 equals 5. I'm still combining like terms, but I need to isolate my x. So I'm going to subtract 8 from here. What I do to one side, I must do to the other. I still need to isolate my variable. So I'm going to divide by 3. What I do to one side, I must do to the other. X equals negative 1. So yay, x equals negative 1. Okay, I'm going to shift this equation over here so that I can work with it. And I am now going to substitute x equals negative 1 into that x. So y equals 2 times negative 1 minus 4. So y equals negative 2 minus 4. Y equals negative 6. So here we go. The solution, remember the solution is an xy. My solution is negative 1, negative 6. So we are using substitution to solve this system of equations. And this is helpful because sometimes it's too hard to solve a system with graphing because either our slopes are wonky or the y-intercept is way off the chart. So when it's not feasible to solve a system of equations by graphing, we can use substitution. So let's do another one. Let's do another one because substitution can look a couple of different ways. So the book has given us this system of equations, y equals 2x plus 3 and y equals 5x. Okay, same thing. I am going to substitute, since y is equal to that, I'm going to substitute all of this for this y. Okay, so now I have 2x plus 3 is equal to 5x. Okay, I'm going to solve this equation just like we did in Unit 1. The first thing I need to do is combine my like terms. So I want to get this over here. I'm going to subtract 2x. What I do to one side, I must do to the other. 3 equals 3x. I want to isolate my variable, so I'm going to divide by 3. What I do to one side, I must do to the other. 1 equals x. Yay! So now I can pick either one of these equations. I can pick either one. I'm going to use this one. Y equals 2x plus 3. And I am now going to substitute 1 for this x. So I've got y equals 2 times 1 plus 3. Y equals 2 plus 3. Y equals 5. So my solution, remember the solution is xy. My solution is 1, 5. So we're substituting here for y. When we figure out our x, we're going to substitute for x. And then there's our x and our y. Let's do another one. Let's do another one. Okay, the book has given us x equals 5y plus 3 and 2x plus 4y equals -1. Both of these are linear equations. They can both be written in slope-intercept form, but we don't need them to be when we're using substitution. So in this case, x is equal to 5y plus 3. X is equal to this. So I'm going to substitute. I'm going to take all of this, and I'm going to substitute it for x. So I'm going to rewrite my equation. 2 times 5y plus 3 plus 4y equals -1. And then I'm going to solve this equation just like I would any other equation. First, I'm going to use my distributive property. 2 times 5y is 10y. 2 times 3 is 6, plus 4y equals -1. Now I need to combine my like terms. 10y plus 4y is 14y, plus 6 equals -1. I'm still going to combine like terms, but I want to isolate my variable. So I'm going to get rid of this positive 6. I'm going to subtract 6. What I do to one side, I must do to the other. 14y equals negative 7. I want to isolate my variable, so I'm going to divide by 14. What I do to one side, I must do to the other. Y equals negative 1/2. Okay, so I'm going to pick, I can pick either equation, but I'm going to pick the one that looks the easiest. And here, this looks the easiest because x is already isolated. So now I'm going to substitute negative 1/2 in for my y right here. So x equals 5 times negative 1/2 plus 3. Okay, x equals 5 times negative 1/2 is negative 2 1/2 plus 3. X equals negative 2 1/2 plus 3 is positive 1/2. So here's my x, here's my y. Remember, the solution is xy. So here's my x, and here is my y. There we go. Okay, the only way to know whether you truly understand this or not is to try one on your own. So I want you to try this one on your own. Y equals 3x minus 4 and 5x minus 2y equals 10. I want you to try this on your own, and I want you to type the solution into the chat. Okay, let's go ahead and solve this. I am going to substitute 3x minus 4 for y. So 5x minus 2 times 3x minus 4 equals 10. So we're going to solve this equation like we would any other equation. The first thing I want to do is distribute negative 6x plus 8 equals 10. Now I want to combine like terms. So negative x plus 8 equals 10. I want to isolate x, so subtract 8. What I do to one side, I must do to the other. Negative x equals 2. I don't like that negative with the x, so I'm going to multiply this side by negative 1 and this side by negative 1. So negative 1 times negative x is positive x. 2 times negative 1 is negative 2. Okay, now I'm going to pick either, I can pick either equation. I'm going to pick the one that looks the easiest to work with. Y equals 3x minus 4. And now I am going to substitute negative 2 for x. So I now have y equals 3 times negative 2 minus 4. Y equals negative 6 minus 4. Y equals negative 10. So the solution is an ordered pair, x, y. My x is negative 2. My y is negative 10. So that's what we're doing today. We are using substitution to solve systems of equations because sometimes graphing is not a feasible option.